Alright, so today we're going to do your kinematic review. So what we have here is a question concerns the motion of a car on a straight track, so no turning. Car's velocity is shown, so that's velocity. That will matter. Alright, part A, describe what happens to the car at t equals 1. Right there, so what happens? The velocity is going up, and then the velocity is going down. Does that mean the car stopped? No, because the car is at 20. So the car is going to stop accelerating. So they were speeding up, and now they're slowing down. Car stopped accelerating. Began to decelerate. Whatever. It's something like that. Ta-da! That's it for that one. Easy. How was the car's average velocity between 0 and 1 compared to the average velocity between, probably the rest of it, 1 and 7. Or sorry, 1 and 5. 1 and 5. Let's get rid of that line. 1 and 5. Okay. Don't worry, you don't need calculus for this. So if we wanted to figure out what's the average velocity, well, it's a straight line. Don't need to do calc. What's the midpoint? 10. So I'll call this area. So V bar is equal to 10 meters per second in red. Compared to the blue area, we're going 20 to 5. Where's the midpoint? The midpoint's right about there. Where is it at? It's at 10. So V bar is equal to 10 meters per second. How do they compare? They are the same. Ta-da! Next. This question concerns motion, or what's the displacement? All right. So things to remember. Displacement is equal to velocity times time. Remember that one? I hope so. So here you have time, here you have velocity. You are going to add up the area. What kind of shape is that? It's a triangle. So we are going to have 1/2 times base times height. This base is going to be 5. The height is going to be 20. And then there's another triangle right here. We'll put it in a different color. That's a negative triangle because it's a negative height. So we'll put a plus. I mean, it doesn't matter how you do it. What's the base? The base is 2. What's the height? The height is negative 10. So going down. We're yelling timber. So simplify, simplify, simplify. We're going to get 40 meters. Ta-da! Next one. Plot the car's acceleration during this interval as a function of time. All right, so here's acceleration. Remember when you do a graph, you should put some units on there, meters per second squared. Here's time. So we are going to go 1, 2, 3, 4, 5, 6, 7 seconds. Hopefully our acceleration stays positive, but I doubt it. Okay, so in this first second here, how do we calculate acceleration? Remember, acceleration is equal to the change in velocity divided by the change in time. It's just slope. So what's the slope here? You go over 1 up by 10. That means your acceleration is 10. So we're going to start off here. Boom, boom. What's your slope here? You're going to go over by 4, down by 20. So 20 divided by 4 is negative 5. So we're going to have negative 5, and then we're going to go here, and that's going to go all the way to 7. And that's it. Ta-da! Easy. All right, make a sketch of the object's position as an interval of time. Okay, easy. So position, we'll call it distance, displacement, position, p, whatever. The letter doesn't matter here. Units are in meters. This is time, which is in seconds. All right, 1, 2, 3, 4, 5, 6, 7. Well, we already know one of these here. We already know it ends at 40 from last question or whatever. So that's a point we know. We know it starts at x equals 0. How about that plus c? And then how's it going to get from there to there? It's not going to be a straight line. We're going to do the same thing like we did last time. We're going to do it in sections here. So this triangle right here is going to be 1 times 20 times a half. So it's going to go up to 10. I'm doing these by tens. So there's the first second. This triangle right here is going to be a 4 by 20 by half. So 40. So it's going to go up by 40. So 1, 2, 3, 4, 5. There's 5. So it's going to go up by 40. So we're going to be at 50 altogether. And that's that second number 5 here. And then we know about that one already. So what's going to happen? Is it going to be a straight line? No, it's going to be a parabola. It's going to start at the vertex of the parabola because your velocity starts at 0. So you're going to accelerate up. This is going to be as steep as you get. After this, it's going to flatten out. You're going to be level again at 5 because your velocity is 0. So it's going to go like this. It's going to make a smooth curve. Something like that. Perfect intersection. All right, and then it's going to start going down. Boom, something like that. All right, and that's it. Ta-da! Do the next one. Hey, we have a projectile moving with a parabolic trajectory, constant gravitational acceleration. How unique. Its initial velocity has a magnitude of v0 and has an angle of theta 0. How wonderful. Okay, so here's what's happening. It's going up there. Here's theta 0. Here is v0. So we want to know the height. To figure out the height, we're going to have to figure out this guy. This guy is sine v0 sine theta 0. Ta-da! All right, so now we're going to use one of our famous equations. We're going to use the third one. V squared is equal to v0 squared plus 2ad. Oh, the height is h, so let's use that. What's the height at the highest? Oh, 0. 0 squared, if you're really into that. What's the starting velocity? It's going to be this one because we're in the y direction here. v0 sine theta squared, put that in parentheses, plus 2. And then we have a gravity in there, so let's just call it negative g because it's going the opposite way as that velocity, times h, because h is what they want for height. And you just got to solve for h now. So h is going to equal, let's move the h over to the other side so the g turns positive. So we're going to get v0 squared sine squared theta 0 divided by 2g. And that's it for that. Let's keep going. This time they want the range of the projectile. Now there is a formula for it. I'm not gonna, well, I guess since you have open notes on your AP test, you should know it. Your range formula is equal to v squared sine of 2 theta divided by g. That's some formula you should know. Well, since you have open notes, I mean, why wouldn't you want to have it on there? But let's assume you didn't remember that. Okay, so what we're going to do now is we're going to figure it out like we did the previous one. So this is v0, and this is a theta 0. Okie dokie. From here on out, I'm just going to call it v and theta. All right, I've gotten tired of writing the subscripts there, and there aren't anything for it to compete with. So this side right here is going to be v cosine theta. That's the bottom part of this triangle here. So what we're going to have to do now is we're going to have to figure out how long it takes. We're going to have to figure out the time in this. All right, so remember that for a future part of this here. So we're going to use the second equation. D is equal to d0 plus v0t plus 1/2 at squared. So we know most of these things here. It's starting from 0. It's ending at 0 again because it's hitting the ground. Plus v0 is going to be this. That's the starting velocity. V cosine theta plus 1/2. And it's going to be negative g because it's going down Oh, yeah. Oh, hold on. This one's not cosine. My bad. This one is sine because this is v sine theta. Because we're in the y coordinate system right now. Because we have to figure out the time. The time depends on the height, and then we're going to use the time to figure out the distance. All right. So times t squared, and there should be a t right there. All right. So we have to solve this for t. All right. Believe me, it's fun. You can divide by a t. Well, I mean, but you mathematicians might be cringing at that. So we'll play it safe and we'll just factor out a t. And then what you're going to have left over is a v sine theta minus 1/2 gt. All right, so far so good. One solution is, hey, t is equal to 0, but we don't really care about that one. So we're going to solve for the other one. So t is going to equal, boom, put it over there. So v sine theta over g, 1/2 down there. So we'll put the 2 up top. So this is the time it takes. All right, remember that for part D. And then what we're going to do now is we're going to figure out how far it goes in that time. Because distance is equal to time times velocity. All right, so distance, or as they call it, range, is going to equal time. Time is 2v sine theta, which you just figured out, divided by g, times velocity is this, because this is in the x direction now, so times v cosine theta. All right, multiplying all these guys together, r is going to equal 2 times v squared times sine theta times cosine theta over g. Now, these guys have a trig identity. Maybe you remember it, maybe you don't. Now, because if you use the half angle formula, or well, the double angle formula, I guess, it's going to be sine times cosine plus sine times cosine. Now, since those two halves are going to be the same, they add up and it's just doubled. So what this is going to degrade into is it's going to be the same thing as v squared sine 2 theta over g, which is the same thing I told you a long time ago, and it would have been a lot easier if you just remembered it, huh? Okay, so that's how you figure out the range of the projectile for anything like that. Hey, for what value of theta 0 will the range be maximized? Well, we just figured out the formula where r is equal to v squared sine of 2 theta divided by g. Let's look at it here. Well, for what value of this will it be the maximum? Well, these guys aren't going to be affected. So we're looking at here. When will sine be at its maximum? Well, sine will be at its maximum when you have sine of 90 degrees. So 90 degrees has to equal 2 theta, so theta is equal to 45 degrees. Yes, that is it. It won't always be true if you're on a ledge, but when you're shooting from ground level to ground level, 45 is the best. All right, one more. So we got a projectile with a parabolic trajectory under constant gravitational acceleration. Its initial velocity has a, sorry, it's the same thing. If h is between there and there, so you're not at the top yet, compute the time that elapses between passing through the horizontal line of height h in both directions, ascending and descending. That is, compute the time required for the projectile to pass through the 2 points. All right, so we've got this point and this point. How long does it take to go from there to there? Okay, well, I misread it before, but that's all right. So what we're going to do actually is we're going to split it in half, and then we're just going to figure out how far to go from there to there, and that's it. The reason why we're doing the right-hand side is we know about this guy. I know his speed there because there isn't any vertical speed, right? So Vy is equal to 0 at that spot. And Vx is the same thing that it's been this whole time, which is the V0 cosine theta of the original situation here. So to go from here to there, at h, we have to figure out the change in height here. We'll call that some letter h. We'll call it k. K is a good friend of h. I don't know, whatever. Okay, so what we're doing now is we're basically just dropping the ball here. Seems like we've been doing that all semester, right? Anyways, so to figure out that, k is going to equal our starting height, which is big H, right? And then, I don't want to do that. So k is going to equal, just start at 0. Start with no velocity, because remember this is in the y direction here, plus 1/2 g t squared. So this is what we're solving for. We're solving for t. Nice. Okay, so solving for t, these don't matter, boom, boom. So we're going to get 2k over g squared root is equal to t. Mr. King, it doesn't matter because, well, there's no k in the real problem. Yeah. So how is k related to this? Okay, so what we're looking for here is that k is going to be big H minus little h. All right, so we're allowed to keep little h because that's the variable we know. We know what big H is because we solved for it earlier in the problem. All right, so big H, in case you forgot, is going to equal, where'd it go? There it is. So it's going to be v squared sine squared theta divided by 2g. That minus h is equal to k. All right, so we're going to stick this whole thing in for here. This is just so we could focus on one piece at a time. That's what that maneuver was. So we're going to have big square root sine 2 times, oh boy, look at that gross stuff. V squared sine squared theta over 2g minus h parentheses all over g, all square root. That's almost right. The last thing we got to do is throw a 2 out in front is equal to t. The reason is because we got to do forwards and backwards the whole thing. We were just doing one and then doubling it. And that's it. That's what it's looking for. So this is the time it takes to pass through the two heights of h. Ta-da. All right, and that should make sense because if you do it at the maximum, right, the maximum level is these two parts are going to be the same, which gives it a 0, which you plug it in here and you get times 0 because there's no time in between going through the same point. All right, that was it. Not too bad. I would not simplify that at all. I would leave it the way it is. It's good enough. They can simplify it themselves. A cannonball is shot with an initial speed of 50 at an angle of 40 towards a castle wall at 220 meters away. The height of the wall is 30. Assume the effects of air resistance are negligible. Ah, that wonderful air. All right, so this is 50. This is 40 degrees. And here's our big castle wall. Beautiful. It's 220 away and 30 tall. So we have to show that we're actually going to hit the wall. All right. So not too bad. We're going to do it in a couple steps. The first thing we got to figure out is, let's figure out these component velocities here. So this is 32.1 and this one is 38.3. Ta-da! Because sine cosine. Alrighty, so what we're going to do now is we're going to do the horizontal first because I know the horizontal speed, I know the horizontal distance, that's going to determine the time. I'm assuming it's going to hit already, okay? Because, I mean, read the verbiage in part A. So distance is equal to velocity times time. Distance is 220. is equal to 38.3 times t. Time it takes is going to be 5.74. All right, so if it makes it, it'll make it in 5.74 seconds. So now all I got to do is find out the height at 5.74 seconds. So the formula for that is d is equal to d0 plus v0t plus 1/2 g, well, a, whatever, t squared. Okay, plugging these in here, we get 0 because we're starting on the ground, plus v0 is going to be 32.1 times 5.74 minus, because gravity is going to be pulling it down, 1/2 times 9.8 times t is 5.74, parentheses squared, boom, 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 boom. Type all that in your calculator, you get 22.7. What does that mean? It means that it's going to be at height 22.7, which is on the wall. Ta-da! So there's part A. Let's do part B. How long will it take for the cannonball to strike the wall? Done with part B. At what height above the wall will the cannonball strike? Done with part C. And that's it. That's how it works. Bada bing, bada boom. Next one. A different cannonball is fired at speed of 40. It launched at 30 from a cliff that's 25 feet tall. All right, slightly more difficult. I mean, barely, right? So this is 40. This is an angle of 30 degrees, and this is 25 tall. All right. What is the flight time of the cannonball? Okay, things we know. 30, 60, 90, that's going to be at 20s that way, and we're going to have 34.6 the other side. Nice. Okay, so what is the flight time? Well, we're just going to worry about the y direction now. So d is equal to d0 plus v0t plus 1/2 at squared. That's what we're going to do. What's the final height? Well, 0, right? Is equal to starting height is 25 this time, plus v0. V0 is 20 times t, plus 1/2 times a. All right. Now, so we'll call it minus 4.9 t squared. Okay. So what we gotta do is solve for t. You have a choice here. Option 1, do the quadratic formula. Nothing wrong with that. Who's afraid of a little quadratic formula? Option 2, I'm going to round up gravity. I'll show you why. Let's say that gravity is equal to -10. That means this is -5. Now I can just factor. All right, I'm going to do it. Don't worry, I'll wash my hands afterwards. I'm going to divide everything by a -5 and rearrange it at the same time. So I'm going to get t squared minus 4t minus 5. Okay, t. So this will be a +1 and a -5. So t is equal to -1 and, or I guess, or +5. Which one do I care about? I care about this one because, that the other one is that side. I don't care about that. Okay, that's the flight time, 5 seconds. What is the range of the cannonball? Okay, well, let's see. Distance is equal to velocity times time. Velocity is 34.6 times 5. Multiply those together, you get 173.2 meters. Easy. In the two graphs below, plot the horizontal speed of the projectile versus the vertical speed of the projectile versus time. All right, easy. So horizontal speed. Horizontal speed is going to be constant all the time because gravity ain't pulling that way. So what's the constant amount? 34.6. So 34 is going to be something right about there. All right, and that's going to go up until 5. Nothing happens after 5. So we're going to have this guy going something like that. Boom, done. Next one, vertical. All right, vertical one starts out at 20. Now, it says speed, not velocity here, so everything's positive, all right? So what's going to happen? As you fire it upwards, it's going to decrease by gravity. Remember how gravity is 10? So as it goes up, after 1 second, it's going to drop by 10 meters per second. After another second, it's going to drop by 10 meters per second. Because remember, gravity is equal to meters per second. So this is meters per second, this is second, that's the slope of this graph. Now what's going to happen here? We're not going to keep going down. We're not going to keep going down because it's speed. So we're going to start going up because it's absolute value. 1, 2, and 5 seconds, and that's going to be the end. And that's it. And that's what it's going to look like. So it's going to hit the ground at 30. Easy times. Okay. Hope you had fun with that.